Here is a still photograph of a PPI display. Information may be abstracted from the display with a high degree of accuracy by the use of electronic markers. These consist of a range ring and a bearing line. Their intersection forms a datum which may be placed on any selected radar response by this joystick. Although the markers behave as polar coordinates, range and bearing, they are always derived from the north-south and east-west components which are available as voltages on the marker potentiometers. The radar picture and the bearing line are both referenced to true north. That is, north is made to be at the top of the display irrespective of the heading of the aircraft. Now let us suppose that the aircraft is momentarily fixed in space. When the operator moves the joystick, the coordinates x and y of plan range to some arbitrary point P are set up on the marker potentiometers. To convert the rectangular xy coordinates to range and bearing, or polar coordinates, another compounder is used. As before, the angular position of the shaft of the sine-cosine potentiometer gives the bearing of the point P. The potentiometer shaft moves a pair of contacts. These are closed by a roller driven by the mag-slip shaft. When they close, the PPI trace is momentarily brightened and gives the bearing of the point P relative to north. The compounder also delivers the plan range of the point P as a voltage. The radar system, however, measures slant range and not plan range, so that the time scale of the PPI is proportional to slant range. Because of this, the plan range voltage from the compounder must first be converted to slant range voltage by solving this triangle, before it can be used to control a range marker on the PPI. To solve the triangle, two linear potentiometers are set up at right angles. These represent plan range and height. This tape, which links the sliders, represents slant range. The sliders are driven by servo mechanisms, and they continue to move until the voltage on each slider exactly balances the applied voltage. The distances along the potentiometers are then proportional to the applied plan range and height voltages. The tape is made to move the track of a third potentiometer through a distance equal to the hypotenuse of the triangle. This potentiometer, therefore, delivers a voltage proportional to slant range, and this is fed to the waveform generator, where it controls the time delay of a range marker pulse, which brightens the PPI trace at the appropriate range. The point P on the ground, defined by the rectangular coordinates set up on the marker potentiometers, is now marked on the tube by the intersection of the range circle and bearing line. The operator himself completes the servo loop. When he moves the markers onto a response T, the voltages set up on the marker potentiometers represent the planned distances north, south, and east, west to the point T.